So in this lecture I am going to tell you how to solve first order equations which are of higher degree. So in the previous lectures, actually if you remember that all the equations you have encountered, basically they are first order equations and they are all of degree 1. In no equation you can remember they were higher degree terms. Okay, so they are linear equations. So now we are going to take general equation. They are all first order equation, or that is we are going to take all first order equations but not of degree 1, but they can be of higher degree. Okay, so in general this type of equations can have this type of dy dx is to the power n plus p1 is a function of x or y, again dy dx will to the power n minus 1 in this way up to pn. So this powers they are reducing, and here dy dx and pn is equals to 0. This is a general form of any first order equation of degree n. So in connection here, we always use, or we will use a particular type of notation which will help us to minimize notation somehow. So these mathematical notations can reduce their burdens actually. So you can reduce this thing by, if you take this equation dy dx is equals to p, and if you put p everywhere, this equation will be less clumsy. Okay, so if you remember, I have told you that any general first order equation of higher degree can be written in this form. So if you put this notation in terms of this notation, this whole expression comes out p to the power n plus p1 p to the power n minus 1 plus p2 p to the power n minus 2. So if you just remember, or you just don't miss that these two p's are different. This p is small p and this p1 is function, is a capital P. This p2 is function, this is capital P2. Okay, this p minus 1 is capital P, is a function, and this p is dy dx. Okay, so basically this whole thing is basically a function which we take p give. So this is nothing but a function of x, y and p. So how or why? You see that this capital P1, capital P2 up to Pn, they are all functions of x and y. So in these expressions x and y's are there, and another variable p, which is actually dy dx. These things will come, the powers of p will come. So basically this, in this expression can be written down that this is a function of x, y and p, and this function will always denote by capital F. So f of x, y, p is equals to 0. So this is our given equation. Okay, so now how to solve this equation? So we have actually three ways, basically three ways by which we can solve this equation. Number one is if we can solve by, I can say that most of the times these equations you can't solve. Okay, most of the times there are very little or very few examples. I can say very few because most of them are unsolvable. Okay, so the very few which we can solve includes three methods. That means number one, we can solve, or we can solve for p, we can solve for x, we can solve for y. Okay, so there are three methods basically by which we can solve this equation. So sometimes a given equation is given, so you have to identify how to solve. That means by seeing this equation you have to gather experience by solving different problems, that if you, when you see a problem like this, you have to understand, and you have to come out that whether it is solvable for p, solvable for x, or solvable for y. So this thing you have to need practice, and you will have to solve several examples, because this thing is little tricky. Okay, so there are other two types of problems which we say sometimes Clairaut's equation and Lagrange's equation. So Clairaut's equation is very important, actually also very simple thing to solve. Okay, so basically the three methods are there. I'm going to discuss three methods. So, and Clairaut's equation is basically is involved. It's very simple, but basically these two methods are not very independent method, but they are, these three things are only independent. Okay. Basically, these three things are independent. You will see that these two, the solving for x and solving for y, they are like very similar. Okay. So before going into this, I am going to discuss what is meant by solvable for p. So solvable for p, that means you have given an differential equation which is of the form f of xi t is equals to 0. This can be of nth degree. So that means the power of p is at most n. Okay, so now you can factorize this thing. You can factorize this thing in n factors in this way: p minus f1, p minus f2, in this way p minus fn. So you can factorize this thing in n factors. You have given an n degree equation, you can factorize this thing in n factor. Now how to solve this thing? So solution is rather simple. What we do? So we have this n factors is equals to 0. They are multiplied. So you can take this equals to 0 or this equals to 0 in this way. So if you take p minus f1 is equals to 0, so you know p is dy dx is equals to f1 of xy. So say you can solve this equation, and the solution comes out as is again a function of xy, and there will be a constant, because you know whenever we are solving a differential equation, a constant will come, integration constant. This is a first order equation, so one constant will come. We will say that this thing is c1. Okay, so if you solve this thing, assume that the solution is this thing. Now we can again assume p minus f2 is 0, this factor, and again you will come to this point, that is you will get another function f2 which is a function of xy, and c2 is another constant, is equals to 0. So in this way you can get n functions, okay, f1, f2 up to fn for each of these factors. So now how to write the general solution of what given differential equation? Since the given differential equation, this is n degree equation, but this is a first order equation. So any first order equation should have only one constant. Okay, so what we do, we take these all c's, the c1, c2, c3, every c are equal, and this common c we say is c. So we multiply these things and change this all c1, c2 by common c, and we come to the solution. Okay, this is the general solution of the given equation, given linear first order equations of higher degree. Okay, these things we say that the equation is solvable for p. This thing means this given equation can be factored out in factors. Okay, This is the thing. So we need an example to understand the basic thing. So let us say we have given this equation. Okay, so if you check, this is a polynomial in P. This P cube term is there, P square term is there in this way. So you know your basic high school algebra, so you can check that. I am leaving it for you, but you can do it on your own, that this equation can be factored out into 3 factors: p xp minus y, yp plus x is equals to 0. You can see, or you can check it on your own. This is the fact. This equation can be factored out in 3 factors. So number 1 factors is p. So the first thing will give you p is equals to 0. So dy dx is equals to 0. So if you move dx that side and you integrate it, and you will get y is equals to c. And now come to this 2. So here we have xp minus 2y is equals to 0. So if you put dy dx in place of p, and this thing will become this, and now you can solve this equation, because you know this equation is first order equation and first degree equation. So you have known methods of solving this equation, so you can always solve. So if you see that, if you solve this equation, the solution is y is equals to cx square. Okay, we can check the solution. Okay, and the third one, this is yp plus x equals to 0. Okay, so this thing is again first order equation, first degree equation. If you integrate this thing out, you will get y square plus x square is equals to 2c. So if you check that, I have taken c in all cases. So no c1, c2, c3, but we have taken particularly c in all the cases. So the general solution will become y minus c, y minus c x square, x square plus y square minus 2c is equals to 0. So this is the solution for given differential equation. This. So I have given some examples for you. You should try to solve these equations.